Thank you for joining Supercharging Your AI Platform with Anyscale. My name is Dominic Catalano. I'm one of our product managers here at Anyscale, focused on the platform, infrastructure, security, and other capabilities powering our platform. We view Ray as the leading compute engine for the next generation of AI, and we like to refer to Anyscale as an F1 race car. We like this metaphor because building an F1 race car comes down to the same characteristics of building an AI platform: power, speed, efficiency, and control. We chose this because if you're an AI platform leader, likely you're choosing between these attributes for yourself and your teams. Now, what do I mean by this? When it comes to power, you need to put all of the compute available in the hands of your developers. You need to give them all of the horsepower they need. Speed. Your drivers, your developers need to be running fast. The race for AI is happening at breakneck speeds, and you need to remove all roadblocks and friction. Efficiency. You need to be firing on all cylinders without burning through the gas, taking advantage of every resource that's available to you. And finally, control. You need common sense guardrails because F1 cars, just like AI, is very powerful, but it can also be rather expensive. Throughout this session, we're going to cover some of the major announcements we covered in Ray Summit, but also dive deeper into the actual infrastructure stack. We'll talk about our compute management capabilities on our cloud native, machine pool, and Kubernetes-based offerings. We'll talk about the speed and efficiency that we're able to unlock for developers through our advanced instance manager and spot optimization. And we'll also talk about the Anyscale Governance Suite, providing those guardrails to make AI sustainable for your business. Let's start with power. When we talk about power, we're really talking about leveraging compute wherever it is on whatever compute substrate and making it easy for people to access this compute for their own purposes, making it easy to develop, but also move things into production. Anyscale first started out with cloud native support for Amazon EC2 and Google GCE, offering full stack optimizations on these platforms. With this stack, we're able to launch very large Ray clusters inside of a customer account. For context, Anyscale operates in a control plane data plane type architecture, where a control plane is able to manage many, many thousands of Ray clusters all over the world inside of customer tenants. We do this by assuming cross-account roles to directly access the Cloud VM APIs, spinning up clusters very quickly. Because of this, we're able to optimize the start path as well. We can go from 0 machines running in a customer VPC to literally thousands in less than 60 seconds. Oftentimes, the only thing slowing us down are API rate limits and capacity issues. Now, because we're managing the control plane separately, we're able to get holistic views about the health of the cluster. We're able to detect things like GPU failures and cycle those nodes through a cluster. We're able to detect disk pressure and alert users about that behavior. And we're also able to do some really exciting things with spot preemption. And we'll talk a little bit more about that later. Because we're using raw VMs, we also have access to pretty much any instance type that's available in the cloud. So regardless of if you want to use NVMe disks for high I/O applications, or there are new accelerators, we can make these available via Anyscale very quickly, instead of having to go through Terraform and redeploying node groups and making things available via something like Kubernetes. Now, this platform works very well, but it doesn't unlock capacity for everyone. The last few years in particular have been evidence that the clouds, while very powerful, are not insufficient or not infinitely scalable. We've all seen this error: insufficient capacity. This error, as well as cost considerations, have forced many companies to reevaluate their cloud strategies and start taking a look at on-prem or on-prem-like infrastructure to support their AI needs. Anyscale itself is no different. We ourselves needed to go ahead and provision some on-prem infrastructure to support our AI researchers, our developers. But we couldn't stop there. We needed to make these machines available to our researchers in a way that made sense for them. We didn't want our researchers fighting over capacity or having to SSH into machines or deal with dependencies or installing Ray or networking or debugging the connectivity. So this is why we built Anyscale machine pools, allowing us to take our cloud infrastructure and extend it on-premise. Let's see how that works. Anyscale machine pools works by allocating a machine pool and then installing an agent on any VM or bare metal machine. This agent communicates to the Anyscale control plane and registers health and activity. It's kind of like building your own private EC2 service. So when you want to launch a cluster, Anyscale can spin up the head node inside of the cloud and instruct the machine agent on what cluster to join, what dependencies it needs, and how to communicate with the head node, all transparent to the end user. But we've taken even a step further. We've exposed these machines just like other instance types within the cloud. Your on-prem compute can just be represented by an instance type, and we'll see this a little bit later. This simple experience makes it very easy for researchers to leverage these machines in a way that's fair across all of the different researchers. Now, when a cluster is done, when it's terminated, Anyscale will deprovision the machine from that cluster and free it back into the machine pool, making it available for the next user without an SRE or anyone else having to go in and clean up that machine. But we also know that VMs and even on-prem doesn't unlock compute for everyone. We know that the vast majority of companies that are serious about AI are doing it on top of Kubernetes. They're deploying Ray using KubeRay on top of their existing Kubernetes clusters. So to support that, we're excited to launch the Anyscale operator for Kubernetes, allowing you to bring your existing Kubernetes clusters to the Anyscale platform. We wanted to take the known pattern of the KubeRay operator and how it manages pods on Kubernetes and provide all of the capabilities of the Anyscale platform. Not only our UI, but our APIs, observability, security, health checks, so on and so forth. And of course, RayTurbo. You may be familiar with this diagram showing how KubeRay can be deployed on top of any Kubernetes substrate. Very similarly, the Anyscale operator is deployed on top of any Kubernetes substrate as long as it can communicate back to the control plane. So whether you're running EKS, GKE, AKS, OKE, or even self-managing Kubernetes, Anyscale can turbocharge your Ray clusters as part of your AI platform. Let's dive a little deeper into how this actually works. To get started, you of course need an Anyscale account. Once you have an account, you can register a cloud, what we call a deployment, to the Anyscale platform, where you'll get a token. That token is used to install the Anyscale operator via Helm onto your cluster. The operator will then assume responsibility for provisioning the pods required for jobs, services, and workspaces, all within a dedicated namespace. So your Anyscale workloads can run alongside other workloads inside of your Kubernetes clusters. Now with this, you also get our comprehensive set of APIs and observability capabilities. So you're able to offload all of that painful development of state management, of integration to Anyscale, greatly simplifying the MLOps story. So to be clear, whether you're running on cloud-native VMs, whether you need to leverage hybrid infrastructure with on-prem resources, or whether you're running Kubernetes, Anyscale can turbocharge your Ray workloads. Let's switch gears and talk about speed and efficiency. It's great that we can manage Ray clusters on pretty much any compute substrate, but what are we doing to empower developers to move quickly without breaking the bank? We've all been through the pain of waiting 5, 10, 20, 30, even more minutes for large clusters to spin up. And then realizing after all of that, you needed to change a config or you need a different instance type, and you have to go through the whole process again. It's slow, it's frustrating, it does nothing but hold us back. And that's why we built the Advanced Instance Manager, capable of launching massive Ray clusters and handling the scale of modern-day AI. The Advanced Instance Manager is designed to handle massive Ray clusters. I'm talking 8,000 nodes and more, spanning millions of cores in a single cluster. And of course, you can have as many clusters as you need. Because we're managing clusters in our control plane, we're able to handle complex errors like hardware failure and recover those machines with either new nodes or shifting the workload to a different machine. We're able to have awareness of capacity across an entire region, as well as understand the price performance at every single machine type. We're able to go well beyond capabilities of open source in how we manage clusters. Not only can we do traditional worker groups, we can provide advanced auto-scaling capabilities to prefer things like reservations or spot or on-demand. But we've taken it a step further with automatic worker node selection. This feature allows you to define the shape of your Ray cluster in your code instead of in a separate config. Just by changing your Ray code, Anyscale can change the shape of your cluster in order to land the resources required. So instead of having to change a YAML file, maybe some Terraform, git commit, make that go through the process, get someone to approve it, wait for automation to deploy it, wait 10, 20, 30 minutes for a cluster to change, and then run your experiment, you can do it instantaneously. Fundamentally, the Advanced Instance Manager is allowing you to focus on your AI workloads, accelerating your development process so you can focus on those problems instead of the underlying machines. But we're also aware of Spot. We understand that Spot is a great way to lower your costs of compute infrastructure. And that's why we've put in a lot of work to understand the Spot capacity across the world. Using a single flag, you can tell Anyscale to search an entire region for a Spot instance before pulling an on-demand instance. And when Spot becomes available, we can move that workload back to a Spot machine for ongoing cost optimization. What we see here is a dashboard of some workloads that I ran a couple weeks ago using a variety of different GPU types. And even though I have some very large 1,000-node clusters, even though I have a mix of different GPUs that are being used, we're able to achieve pretty high Spot utilization across the board just by being aware of the changing capacity. So the Advanced Instance Manager is allowing your folks to move fast, save money, and continue focusing on their development work. But let's actually go into the console and see some of these things in action. Let's say we're operating inside of one of our AWS deployments of Anyscale, and we want to run a rather large workload using 100 Trainium, 100 Inferentia, and 100 L40S GPUs. Let's go ahead and start this up. I've configured this cluster to use our Spot fallback capability. So across all of these different worker groups, it's going to look for Spot and then fall back to on-demand. And it's doing this all in parallel at the same time. Now, of course, if you don't want us to look across all availability zones, you can, of course, disable this as well, giving you that control. But if we look at some of these logs, some of these things should be fairly expected. L40Ss are pretty popular, so insufficient capacity on Spot is not super uncommon. Here we see that the head node is launched and it's already pulling the Ray container. And we are working through the acquisition of all of these different nodes. So in a couple minutes, of course, capacity will be an issue where we will hopefully be able to launch this cluster. Yeah. So here we see that we already have some nodes coming up. So this should be ready in a few more seconds. We see this starting up, but let's say we actually want to leverage machine pools. Say we just got a GH200 on-prem and we want to run some experiments. Prior to this webinar, I went ahead and logged into our new machine. I registered it to Anyscale and give our workspace a name. And that machine now shows up in our instance dropdown. You can see it's located in our US West data center. And we totally have this definitely real GH200 that I provisioned. We're able to leverage everything else with workspaces. We're able to select our image. We have custom images as well. You can bring your own. And all I have to do is click create. In the background, Anyscale is instructing this machine to join my cluster. And we can see that this machine has been allocated, and we're starting the startup process. So the machine has joined my cluster, it is downloading my image, and this workspace should be available in a minute. Let's take a look at automatic worker node selection. Here, I actually switched over to our GCP deployment inside of US West 1, and I can run some code. This code is fairly straightforward. It's just a single function called 3 times, one asking for just a CPU, the other asking for one NVIDIA L4, and another asking for 4 T4s on one device. What Anyscale is able to do is pick up that auto-scaling request and map it to the most cost-efficient resource inside of GCP that's able to land it. So in a few moments, we're going to be able to see the instance spin up. See, we already have a G2 starting up inside of US West 1A, and we'll get a T4 in a moment. But what about Kubernetes? Kubernetes is slightly different in that you don't have set instance types, but that's okay. We actually give you the ability to define your own instance types as well. So here I have a GKE deployment of Anyscale alongside my many, many others. And I'm able to specify the node types that are predefined when I deployed the Anyscale operator. And I can configure this however I want. Different shapes of machines, different GPUs. It all depends on what node pools are available inside of your cluster. But starting a workspace on top of Kubernetes is just as easy as any other stack. So just to recap, we were able to launch a 301 node cluster on top of AWS, a cluster that is leveraging some on-prem compute, a cluster that is now scaling up to support different GPUs using the automatic worker node selection, and we see a workspace starting up on top of Kubernetes. 4 different ways to run Anyscale. But what's important is that all of these resources are available to you in one view. You're able to look at all of your different compute workloads across all of your different clouds, deployment models, and importantly, at the end of the day, have an easy way to turn things off. Lastly, let's talk about control. Backing all of this is the Anyscale Governance Suite, providing the controls and guardrails you need to make AI sustainable for your business. When we think about controls, we put them into 2 different categories, proactive and reactive. When we say proactive controls, we're talking about guardrails that can be set up to prevent overuse, overspending, and enable the fair allocation of resources. Reactive controls have more to do with that 3 a.m. call from your CFO asking what happened the last day. But let's dive into it. When it comes to proactive controls, traditional approaches generally don't work. You can't limit the instance types or the shape of the cluster or say you can only use X, Y, and Z because AI comes in many shapes and it's changing all the time. So how do you manage cost in that scenario? Well, of course, we offer budgets allowing you to define spend limits at different levels, whether it's the deployment cloud or the project or even the user. But we also provide more flexible options. Resource quotas allow you to find limits on the number of resources being used on a per cloud, project, or even user level. You're able to specify limits on the number of CPUs, the number of instances, the number of GPUs, even down to the GPU type. So this method allows you to be very flexible in how you define who has access to what. Very senior engineers can have access to your H100s, whereas others may only have access to A10s. You may want to make sure that your production environment has more capacity, but your staging environment can use up to 4 A10s or 8 100s if necessary. Resource quotas allow you to be very flexible and scale with the needs of your organization. Let's talk about reactive controls. Reactive controls exist to validate who performed what in order to ensure transparency and accountability. To offer this, we offer a number of tools, like audit logs, allowing you to capture who accessed what APIs when within Anyscale. Detailed usage logs, allowing you to capture platform usage down to the instance type second per cluster, per user, per cloud, giving you extreme levels of transparency about the usage of the platform. And automatic resource tagging. Anyscale will automatically apply tags within your cloud environment to basically share all of the information we have in the detailed usage log. Using these two capabilities, you're able to join the data sets and have a holistic understanding of who used what within your platform. So to recap, Anyscale is offering the power to supercharge your AI platform, regardless if you're on cloud native, on-prem, or on Kubernetes, anywhere in the world. The speed and efficiency to compete in the race for AI and the controls you need to stay in the race for as long as you need. So thank you for joining this session. As a shameless plug, we are hiring. So if you are interested, please visit our careers page and help shape the future of AI.